Hello everyone, welcome to Sir Rob's Math Lab. Now today we're going to look at this geometric proof question. So here we have A, B, C, D is a quadrilateral. Prove that X is equal to Y. So let's have a look at this diagram here. So for this diagram here, we can see that a quadrilateral has been inscribed in a circle and all of the vertices touches the circumference. All right, all of the vertices it touch the circumference. So this is called a cyclic quadrilateral. All right, now a cyclic quadrilateral is basically a quadrilateral inscribed in a circle for which all the vertices touches the circumference. Okay, so let's have a look at this now. Now, when we're doing circle theorem, we remember the cyclic quadrilateral theorem, yeah, which says that opposite angle in a cyclic quadrilateral, it adds up to give us 180 degrees. Good. Now, opposite angle in a cyclic quadrilateral, it adds up to give us 180 degrees. So here, this one would be opposite to that. So if we add these two, we should get 180 degrees. So let's go ahead and do that. So you're going to have 4x plus 5x is equal to 180 degrees. So this can be simplified to give us 9x is equal to 180 degrees. So let's look at the other one now. So this one is opposite to this one. So these two, when added, it must be equal to 180 degrees. So here we're going to have 2y plus 2x plus 5y equals to 180 degrees. Okay, so let's go ahead and simplify this. So we can say 7y plus 2x is equal to 180 degrees. Now here we have 9x equals to 180 degrees, and here we have 7y plus 2x is equal to 180 degrees. Now if both of them are equal to 180 degrees, we can say both of these are equal. So let's go ahead and do that. So we can say that 9x is equal to 7y plus 2x, because both of them equals to 180 degrees. Now here we want to get all the x on one side of the equation. So here we're going to subtract 2x from both sides. So let's go ahead and subtract 2x from both sides. So 9x minus 2x, we're left with 7x. And here 2x minus x, 2x, that's 0. So we're left with 7y here. Now, if we divide both sides of the equation by 7, we realize that x is equal to y. And therefore, we have proven that x is equal to y. All right. All right, so we could use an alternative method as well. So let's go ahead and look at another way in which we could look at this question here. So as you know, it is a cyclic quadrilateral. Opposite angle in a cyclic quadrilateral adds up to give us 180 degrees. So let's go. So 5x plus 4x which is equal to 180 degrees. So that's going to give us 9x equals to 180 degrees. Need to solve for x. solve for x, we're going to divide both sides of the equation by 9. So x is equal to 20. So the value of x is 20. Now, if we look at this one now here, where it is opposite to each other, we're going to add them and equate it to 180 degrees. So let's go ahead and add those angles. So we have 2y plus 2x plus 5y equals to 180 degrees. Now let's go ahead and simplify the left-hand side of the equation. So 5y plus 2y, that's going to give us 7y plus 2x, which is equal to 180 degrees. Now we can recall that x is equal to 20, so we can substitute x for 20. So 7y plus 2 times 20, which is equal to 180. 7y plus 40, which is equal to 180 degrees. Now to solve for y, we're going to subtract 40 from both sides. So if we subtract 40 from both sides, we will be left with 7y is equal to 140. Good. Now from here, we can go right ahead and solve for y. Now to solve for y, we divide both sides by y. So let's go over here. 7y is equal to 140. Divide both sides of the equation by 7. Y is equal to 20. So here we go. Y is equal to 20. X is equal to 20. So x is equal to y. Therefore, x is equal to y. And there you go. You could have used this method to prove it as well. Thank you very much for watching.